Good morning, everyone, and welcome to this special meeting of a time series database essentials. Today we have a special mission briefing where we're going to build a high availability TDengine cluster in order to achieve fault tolerance and complete our mission. I'm Joel Brass, Solutions Architect for TDengine, and today I'm bringing you our special webinar. I'll be giving you an introduction to TDengine. We'll also talk about what is high availability. I'll show you TDengine's high availability architecture, and then I'll demo how you can complete this mission using TDengine's high availability features. TDengine is a high-performance, scalable time series database that was purposely built for industrial IoT applications. It has a zero-code data consolidation tooling that can be used across many industrial sites, systems, and protocols. We support OPC UA, OPC DA, and MQTT. We also work with traditional historians like the Pi system and Wonderware. You can also synchronize between edge nodes and cloud nodes. TDengine supports an open ecosystem with many easy integrations to programming languages like Java and Node.js. We support standard interfaces like JDBC and ODBC to connect to your favorite apps. TDengine is trusted by over 500 customers worldwide. TDengine is used by customers like McDonald's, Siemens, General Electric, and Tesla. Now, today's mission will be achieved through high availability. What is high availability? It's the ability to operate a system continuously even if one of the components fails. In order to have high availability, you need some key things to implement it. You need to have a cluster or multiple servers that function as a unified system. This helps to create the redundancy that's needed in having duplicate components. This redundancy allows us to fail over and have an automatic switching over to our backup or standby systems. And we achieve this through load balancing by distributing the workloads across the different nodes so no single node becomes the point of failure. And of course, we have continuous monitoring and verification of our system health to make sure that no anomalies are happening or we detect them if they do. This is TDengine's high availability architecture, and we are able to store so much data by putting it across different D nodes and storing which volumes they're stored on. TDengine's high availability architecture is achieved by creating a 3-node, 3-replica cluster. In this demo, we're going to create a 3-node, 3-replica cluster with the time series and data, metadata replicated across all 3 nodes. All the data is stored in each one of the high availability servers, including the metadata is stored on each M node, and each D node has all of the data. The servers must also reach a raft consensus algorithm to achieve data consistency. And we use write-ahead logging to log the data so we can store it even before it's committed to disk. It's committed to memory in the write-ahead log in case of a crash. So for our demo today, we'll see that incoming data from our data source is going to a load balancer, which is then in front of our TDengine cluster. We'll also be using Grafana to monitor the situation. And we've just received intelligence that somebody is trying to take out TDengine server number 3. So let's go to our demo and see what we can do about this. So here we have our demo environment that we are monitoring, and we can see right now all is well in the system. Here's our data source that is being used to insert the data into the system. And we can see here in the data source creation that we have said, create our database with 3 replicas. It's a key piece of database creation that tells TDengine to store it across 3 different nodes. For our demo instance and cluster, this is currently running on AWS. We have 3 TDengine database nodes here as cluster node 1, cluster node 2, cluster node 3, and our Nginx server here, which you can see is also a smaller server. We don't need much power there. Now, here's the database that we are protecting. Our renewables HA database is getting live data from the data source. And we can see that here, that the data is coming in and live. And this is data from a solar wind farm coming into the system. We can also see in our TDengine management that our cluster is set up and ready. Our cluster currently has 3 nodes, a leader, and 2 followers. And this is configured when you're setting up TDengine. The first instance that you set up becomes the leader. And when you set up additional nodes, you configure them to be followers for the leader. And we can still see what we're monitoring is all clear. We're getting a continuous data stream. So here on the top, we are seeing the overall power output, and this itself is pointing at our load balancer data source. So this is seeing what the database as a cluster is seeing. And then here on the bottom left, we are monitoring each one of the nodes directly. And these each, this is node 1 directly, instance 1, or node 1, instance 2 directly, and instance 3 directly. And this number here is the number of records that we have received over the last 5 minutes. Now, going back to our diagram, what we're going to do is have a failure here. The bad guys are coming into the system, and what they are doing is stopping TDengine on node 3. So we're stopping the service. The service is failing here on TDengine 3, and we are monitoring the situation to see what happens. And we can see that there's now no data coming in to node 3, or node 3 is no longer available. We've turned the service off, and the rest of our cluster is still receiving data. We still have 3,000 records at Solar Farm A node, and at the instance 1 directly and instance 2 directly. And I'm still, if we look at our management screen here, and the, oops, got logged out. And we can still see here that the cluster is running and we have data. If we rerun this query, we should get the same updated. We got updated data here, and we will also look at the cluster, and we can now see that TD3, node 3 is offline. But still, we've no failure here. So we've realized what happened. We're going to bring TD3 back online. We've realized what happened. We've neutralized the bad guys on this mission. And now we will see the data has been replicated back to node 3, and it is serving data correctly. Now, what happens if the leader is taken out? So here we have TD node 1. We're going to stop here. The bad guys decided to take out the leader node. And now we are looking at our cluster, and we got logged out again. Looking at the cluster, we can now see that TD3 node was elected to be the leader, and we're offline here on node 1 that was taken out. And same here, no data for node 1, but when we bring TD1 back online, instantly we can see that the data came back and was restored, and we have all of the records. So if we cut off the data here, what we did was cut off the data coming in to any one of these different TDengine cluster nodes, but still we were able to see the data and receive the data at Grafana. So even though the bad guys tried to take out our database server, we were still able to thwart them by using high availability in a TDengine cluster and able to monitor it the whole time using Grafana. So that is the end of our demo, and what we will do is go back to the slides. All right, just going to see if there were any questions in the Q&A. Let's see. I don't see any more specific questions, but your mission, should you choose to accept it, is to reach out to TDengine. If you have any further questions, please email jim@TDengine. You can also try TDengine Cloud by going to cloud.tdengine.com. And you can also view our open source offerings and try TDengine yourself at our GitHub page. And definitely come to our website and learn more about TDengine's time series database at tdengine.com. Thank you very much, and see you next time.